So, continuing with 7.5, let's go back to our Saul and Tina playing this game of pennies. Remember, if Saul plays, say, 60% heads, 40% tails, with this payout matrix, or payoff matrix, and Tina plays heads, then Saul wins $1. Tina plays tails, and Saul loses 80 cents. So you think Tina's going to figure that out? I don't know. But you really can't expect Tina to always play heads. So is there another way we can take a look at this to figure some of that out? Well, let's suppose, let's let P equal Saul's probability for head. Saul's prob for heads. Then 1 minus P would be Saul's probabilities for tails, right? And if we take and put that back in here, then we can say, okay, the P and the 1 minus P times the 3, -2, -2, 1. What does that give us? Well, it's a rather long because of the P's in there. $3P plus -2 times 1 minus P. And I'm going to put a little comma here just to separate these. This is a -2P plus 1 minus P. Well, that's what this is. Okay. Let's make this a little nicer. So we get 3P minus 2 plus 2P. So this is 5P, right? Minus 2. And this is a 2P and a negative. So this is -3P plus 1. Okay. Let's assume, and maybe this is a bad assumption, that Tina plays 50-50. Remember, this is the Tina's heads and tails. That's really for this stuff over here, right? So Saul would get this if Tina plays heads and would get this. And if she does 50-50, then these are about half. These would be equal, right? So what is 5P minus 2 equal to -3P plus 1? Add 3P to both sides, we get 8P. Add 2 to both sides, we get 3. So P is 3/8. Let's see. 3/8 is 3.75. 0.375, rather. So that's what you should use here, if you're assuming that she's going to do that. Put in the 0.375 and then the 1 minus P for that. So let's look at this from Tina's point of view. Because we're multiplying on the right now with Tina, we can say that this payoff matrix, and this will use Q for heads and 1 minus Q for tails. So this would be the two different equations, the 3Q and then -2 times 1 minus Q. That's the first position here. -2 times Q and then 1 times 1 minus Q. Set those equal. Let's see, 3Q minus, we'll distribute that 2. Minus 2 plus 2Q. And if we say that, we assume, I guess, that it's going to be a 50-50 again. It's -2Q plus 1 minus Q. So we have 5 Q's here, minus 2. We have a -3Q plus 1. Add 3Q to both sides, 8Q. Add 1 to both sides, 3. Yes, Q is 3/8 also. The same thing. So if they both use this strategy, 3/8, 3/8. Let's first look at it at Saul's point of view. He can do heads or tails, and then heads or tails, or heads or tails. Remember, if they do then 3/8, then 3/8 would be for this, right? I'm sorry. 5/8 would be for that. This would be the 3/8 and the 5/8. The 3/8 and the 5/8. So perhaps you can see if I can get something that writes a little smaller. This is 3/8 times 3/8, or 9/64. 5/8 times 5/8, or 25/64. Both of these, 3/8 times 5/8, 5/8 times 3/8 is 15 and 15/8, or 64. So this is 30/64. So this is heads, heads, this is tails, tails, and this is tails, heads, or heads, tails. So, if we look at Saul's point of view, and we say that Saul is going to get 3, this is the amount, this is the x. He gets 3 cents, or 1 cent, or -2. The p of x. Remember, this is how we're doing this expectation. For the 3, this is the heads, heads. That's the 9/64. The 1 is the tails, tails, 25/64. And the 30/64 is for this -2. The Tina really wins that one. You multiply them together, x times p of x. You get 27/64, 25/64, and a -60/64. When you add those, you get a -1/8 when you reduce things. So a -1/8 of a cent, I guess we're talking cents in the dollars, whatever you'd like. That means really that Tina wins. 1/8 of a cent. So that's from Saul's point of view. In fact, that's sort of an interesting outcome. This game really favors Tina, not Saul. Saul, don't play. Find a different game. Or don't play for money. Get a piece of candy or something like that. Some of your Easter candy. Section 7.5, that's all there is to it. You get to do the problems.